We have been given this Pseudo code, and then we have been asked to draw the corresponding flowchart. So we have start, enter radius. If radius is less than 0, then display error, message and enter positive radius. Else enter height. If height is less than 0, then display error message and enter positive height. And then here we have else volume is equal to 1/3 times pi times square radius times height. And if display volume, and then here we have stop. So the first thing you have to do is know is the shapes. So first here we have start. So here the first thing you're going to do, you're going to draw an oval shape like that, which is for start. So inside there, you're going to write start like that. So that's our first step. So here again, the second step is enter radius. So here notice that we have enter. So enter is an input. So here we are going to draw an arrow going down like that, and then here we are going to draw a parallelogram which is for input. So here we are going to say inside this parallelogram I'm going to write enter R. So here we have enter radius. So instead of writing enter radius, we're just going to say enter R. After writing this, here we have if radius is less than 0. So here notice that we have if radius is less than 0. So that's we have a decision. So we're going to write a parallelogram here. We're going to write a rhombus which looks like a diamond here. So it will be, I'm going to write a rhombus. So here, if radius is less than 0, instead of writing if radius is less than 0, I'm going to write is radius is r less than 0, and then I'm going to write a question mark like that. So that's how I'm going to write it. So then here, notice that we have then. So whenever you see then, you have to draw an arrow like that. So then whenever you see then I'm going to write yes on top of this arrow. So this is then yes. So after writing yes, here we have display. So display is an output. So whenever you see display or enter, you're going to write a parallelogram like that. So I'm going to draw a parallelogram for enter or display. Whenever you see display or enter, you should draw a parallelogram. So after drawing this parallelogram, I'm going to write whatever you see here. So I'm going to say display error message, and the enter positive radius like that. So after writing this, I'm going to move on to this next step, so which says else enter height. So whenever you see else here, you're going to draw an arrow going down like that, and then beside this arrow I'm going to write no, which is for else. So whenever you see else, you should write no like that beside this arrow. So and then here it says enter height. So whenever you see enter here, you're going to draw a parallelogram like that. So I'm going to draw a parallelogram like that, and then inside this parallelogram I'm going to copy what is here. We're going to write enter height. So I'm going to just say enter h. Instead of writing enter height, I'm going to just write enter h. So after writing this, notice this next step. So it says if height is less than 0. So if, whenever you see if, it means there is a decision that is going there. So here it says display error message and re-enter positive radius. So it says re-enter. So re-enter, you're going to re-enter positive radius. So going to draw an arrow going up like that, and then back to enter like that. So the information will be re-entered like that. So be careful in doing these things. So like that. So here I'm going to draw another arrow going down like that. So if height is less than 0, so we're going to draw a decision shape, which is a rhombus, which looks like a diamond. So instead of writing if height is less than 0, I'm going to say is h less than 0, like that. Then after writing like this, notice that here we have then display error message and the enter positive height. So again here, whenever you see then, you're going to light an arrow like that. You're going to draw an arrow, and then on top of this arrow, you're going to light yes. So the yes is for then. So then, whenever you see then, you should do light yes. So like that. So here, notice that you have display. So display, again, display same like here. We're going to display is an output. So we're going to draw a parallelogram for output. So we're going to draw a parallelogram like that. So it should be a parallelogram. And then I'm going to copy whatever we see here. So it's going to copy everything. So it will be display error message and the enter positive radius. So should be radius like that. So and re-enter positive radius. We're going to re-enter positive radius like that. So I'm going to draw an arrow like that, and then going to go back like this to this arrow again. So meaning the information will be re-entered since we have an error here. So like that. So let's move on. Let's go to this step. We were at this step, so now we're going to this step. So notice that it says else. So else, whenever you see else, you're going to draw an arrow like that, and then beside that arrow, we're going to say no, like that. So after lighting that, so notice here again we have volume is equal to 1/3 times pi times whatever stuff is here. So here we have a formula. So for a formula going to be processed, so the formula has to be processed. So we are going to draw a rectangle like that to indicate that we have something that has to be processed. So in this case, which is a formula. So here we have a formula for volume. Sorry, should be VA. V is equal to 1/3 times pi times square radius. So square radius are going to say times r again times h, like that for this. So and then here it says and if display volume. So whenever you see display, we're going to draw a parallelogram. So display is an output, so I'm going to draw a parallelogram for display. So I'm going to say display volume, like that. Display volumes, pardon my handwriting. So display volume, and then here we have stop. So here stop, we're going to draw an oval for stop, like that. So we're going to draw an oval for stop. So inside this oval, we're going to light stop, like that. So that's how you can draw the corresponding flowchart to the pseudocode above, which is this pseudocode. So this is the flowchart, like that.